So this was a previous program which already you might be having. I just rename it to some other file. Okay, so here K is what stiffness. So I require a mass matrix. So I call as mass as a stiffness matrix. Okay, so here init N is there. So that will create a mass matrix as well as the stiffness matrix. So var fix 1, fix 2, Gauss, this I won't require. Console log, this I won't require. Sigma I won't require. Init stiffness I do require. So I'll create a mass matrix also here. Okay, so that needs to be initialized. As the stiffness matrix. Okay, so initialization will be same as for the stiffness matrix as well as the mass matrix. So one function basically it will initialize the stiffness as well as the mass matrix, and which will be initially 0. Okay, so this is what we are trying to prompt, enter the number of nodes. So we are not going to make a generalized, we are going to solve it for only 3 nodes. Okay, so this problem we are going to take. Yeah. So this is what is the problem we are going to solve it. Okay. So I'll just loop them now. So 1, 2, 3 nodes. So I'm going to prompt 3 nodes, and of course I'm going to have a fixed node. So I'm going to create a specialized program for this only. You could create a generalized program, okay, but for that finding the lambda for higher order, you require Drunken's formula or power series method, or maybe the combination of Rayleigh method. So presently that is beyond your curriculum and it is not expected at the undergraduate level. So that those methods we will not be taking it. Okay, so if you study vibration analysis in future classes, maybe at master's level, then you will be able to understand what those methods are there. Okay, so this is what is the problem we'll be trying to solve. So not this. Okay, so here in this case we are going to enter always 3. Okay, or we can fix it 3, no issue. That's the thing. So what I do, I just fix it 3. Okay, so it will be for 3 nodes. I don't require sigma variable. I don't know what this for any I have taken. Okay, this is for the number of elements. Okay, so I am prompting A, I am prompting area, and I am prompting the length. So every time I have to enter different stuff. Okay, so at the same time I'll define the row, and same thing again I will prompt from the user, because for the mass matrix I will require the density of that material. So this is already responsible for creating a stiffness, so I should not worry about this. Okay, now I have to write down. So sigma is not required. Okay, so we require mass matrix. So mass of I, so it is diagonal element. Okay, so first diagonal element will be A row, okay, into area into length of element divided by 6 and multiplied by 2, because first diagonal element is 2 times. So if you see, okay, so here in this case, this is 2. So row ALE by 6 into 2, this will come, and for rest of the elements, it will be 1, and for diagonal, it will be multiplied by 2. Okay, so I just copied this, paste it here, and I say I plus 1 and I plus 1. So this is the second diagonal, okay, and then off diagonal, so this will be plus 1. Now instead I don't need 2 here in this case, so I remove the 2, and the second off diagonal element I will also remove this 2. So in this way my elemental mass matrix will be created. Okay, so just let me know whether you have understood this or not, or you can ask the question. So have you understood this? Just let me know. Anybody else? Okay, so if you haven't got it, you can ask the question. Okay, so this is important. Okay, so assuming that now this is understood to you, so this is the mass matrix what we have created, and automatically assembly will be created. Okay, so because this stiffness, when I write, assembly is created. Similarly, when I write this, the assembly will be created, because that we have taken care. Okay. Okay. So now I'm going to have a specific program. Okay. So now you could clearly see here in this case that I'm going to use this element, this element, this element, and this element. So I can call this as a K22. Okay. So this is my K22, and this is my K23. This is my K21, and this is my K22. So I'm going to write specific for this. Okay, you could make it generalized, but you need the knowledge of higher methods. Similarly, for my mass matrix, I can call this as a M22, M23. This will be M2, M33. So this is not 22. I have written 22. This is M3, K33. Okay, so similarly this will be AM33. Okay, and this will be M31. So this is not 21, so this is M31. So I can say K22, K23, K31. No, this is K23. Okay, third row, second column. Okay, so A32, K32, K33. Okay, this is K22, K23. Again, I repeat, this is K32, K33. Similarly, I will be having M22, M23, M32, and finally M33. So this is what is my mass matrix. Is going to be from the global. So I should not eliminate this. So instead of that, I can directly use it, because I am going to write the program for the specific problem. Okay. So for this only we are going to write. According to that, you can make the changes. So this is what we have to prepare. Okay. So this is my K11, sorry, K22. Okay, lambda into C, sorry, lambda I leave it, C into 300, this will be my M22. Okay, this will be my K23, C into 50, this will be my M23, this will be my K32, and this will be M32, this will be K33, and this will be my M33. Okay, so from this I have to find out what is going to be A, what is going to be B, and what is going to be C. So this is what I have to find out. Okay, so I can see here in this case, so I need to do cross multiplication. Okay, so this into this, so I can see K22 into K33, this into this will be constant. Okay, and that is imparting C. So I can write C equal to K22 into K33. Okay, so this is my constant. So this will be imparting the constant. So I can write C equal to this, and I can keep on adding it. I can keep on adding into the C always. Okay. If any other constant term is resultant, I just keep on adding it. That is how I am going to do it. Now, next is M22 into K33. So this is going to go for the lambda. So that is going to contribute in value of B. Okay, so I can write B as, okay, so that will be M22 into K33. Okay, so this is now contributing to my B. Okay, now again I go back here, and then this will be multiplied. So this will be multiplied to now this factor. Okay, so I could see it is lambda, so again it is contributing to B. Okay, so therefore plus, okay, K22 into M33. So this is contributing to B, and finally I have M22 into M33, and that is contributing to my A. So A equal to M22 into M33. So this is what is my factor which is trying to get the value of A. So just let me know whether you have understood ABC. So you can enter, you can just type by letting ABC if you have understood the ABC. Okay. Okay, so now let's prepare. So I start from A, so that is M22 into M33. So here I can write my A equal to M of 2 into M of 3. So that is my A. Okay, what is my B? B will be equal to, so M22 into K33, okay, and K22 into N33, okay. So it is diagonal. So M22 into K33, okay, plus M33 into K22. Okay, so this is how I got the value of B. Now how I am going to get the C? That is K22 into K33. So this is what is my C. So I can write C equal to K22 into K33. So this is how I got this value. Okay, I just save. Now this was the cross multiplication for the first one. Okay, so I just erase this. Okay, so this is what we have done. Now we have to also subtract after multiplying this. Okay, so now again the same thing, which is contributing to constant. So I can see this K32 and K23, that is contributing to constant. So of course that will be minus. So minus K32 into K23. Okay, so this is contributing to C, and of course I have to minus, subtract it. Okay, so C minus this is whatever the previous value is there, from that we have to go for the subtraction. This is what is the meaning of that by putting this minus. Then M32 into K32, that is contributing to B, but that will be again the subtraction. Okay, whatever the multiplication is there, that is going to go for with the subtraction. So I can write M32 K23, and of course this will be minus. Okay, so this is going for the subtraction. Now next will be K32 into M23, that will also go for the what you say, lambda, and that will be also contributing in the subtraction. Okay, minus K32 M23. Okay, now for A, we are going to contribute M32 and M23, that is going to go for the lambda, and that will be again subtraction. So minus M32 into M23. Okay, so this will add all the subtraction term. So now just let me know whether you have got this thing. So now you can reverse the thing. You can say CBA if you have understood this. Okay, so K32 and K23 subtract from C, 32 and 23, minus K32 okay, into k 2 3. So this is what I have to subtract. Now one important thing, I use k capital, so I need to take care of that. Okay, so that's done. K32 and K23. Okay. Now for B, M32 and M23. So 32 and 23 minus M32 into K23 2 3. Okay, so I'll just take one more time, 32 and 23. Yeah, 32 and 23, correct. Now minus K32 and M23. Okay, so minus K32 into M23. So I double check one more time. So K32 and M23, K32 and M23. Okay, and for C, how these two are same? No, sorry. So K32 and K23 is there. Okay, so only M is changed. So it's easy to remember. So I just copy this, and this is contributing. Okay, for C I have done. For M is M23, M32 and M23. So K की जगह M रखने का है. So B this. So I copy this and put subtraction sign, and instead of M, okay, I put it M. So M32 and M23, 23, M32 and M23. Okay, so this is what I have done. Okay, so such contribution, whatever is there, that I have written. So I got A, B and C. Now it's time to get the lambda. Okay, so I can, so now var, so I need to write here var A, var B, var C. Okay, so var lambda 1. Okay, so it is minus B. Okay, so first I have for P, positive sign, minus B plus minus under root of math dot sqrt under root of B square. So I write B square as B into B minus 4 into A into C. Okay, so this is what I got, divided by 2 into A, twice A. So this is how I got lambda 1. I just copy this and paste it here, and instead of plus I will put the minus. Okay, so hope this is correct. Okay, so let's log console.log lambda 1. Okay, copy this and paste it here and say lambda 2. Okay, so maybe I comment this as a lambda 1 equal to, okay, and I can put plus sign. Here also same thing, I can put lambda 2. So I'll understand which value is which one. So I just hit save. Okay, so what was the area between 100, 50, 1000, 1000 and 7800 and 2 into 10 to the power 5. Okay, so now I just reload this. Okay, enter area. So 150. So first area is 100. E is 2E5. Length is 1000 and row is 7800. Now kg per mm cube. So I need to convert that. Okay, so I just cancel this. So that change I have to make. Okay, so I say rho is equal to rho into 10 e minus 9. Okay, so that is 10 to the power minus 9. Okay, so this is lambda 2. Fine. So rho. So I just change this. Okay, fine, no issue. Now just reload. Enter the area. So first area 100. E2 E5. Okay. Then enter the length 1000. Row is 7800. Enter the area 50. 2E5. Enter the length 1000. 7800. Okay, so I just check the console log. So I got error. Cannot read property 3 of undefined. Yeah. So it starts from 0, not 1, 1. Okay. So that I have to change. 1, 1. This is 2, 2. This is 2. This is 1. This is 1. This is 2. This is 1, 1, 2, 2. Because array starts from 0, so one index I have to go down. 1. Okay, so I hope this will do now. Reload, enter area 100, E2 E5, length 1000, row 7800, area 50, 2E5, length 1000, row 7800. Okay, so I got these values. Okay, so lambda 1 is something like this and lambda 2 is something like this. I don't know why I got the minus. Okay, and here what value I got it? Okay, so some different value I have achieved here in this case. So now you could verify uh, whether our formula is correct or not, or whether while solving we have made the mistake. So that you could verify. Okay, maybe this might be the correct result because I'm getting negative values, and I should not get the negative values in any case. Okay, so maybe while doing this multiplication, I might have made some mistakes. Okay, so minus of this is this. Okay, so this is minus. Okay, that is why this is problem. So all m values, so for k it's fine. K will automatically become minus, but this lambda, that means all m values, I have to take negative. So minus 300. Okay, so all m value has to be negative because it is in the subtraction mode. So that is what I have to do it. Like this, maybe. Okay, so for this also I'll put like this, so it will be visible. So all m value I have to take care that it will be a minus. So I don't need, this is this and this is this. Okay, done, correct. So this will be minus. So this is how actually you have to go and start building the program. Okay, so it's not that difficult. You keep on debugging and try to see where you have made the mistake, and in this way you can work out the stuff. Okay, so hope this time I'll get the correct results. So I just reload, enter area 100, E2 E5, length 1000, row 7800, area 50, 2E5, length 1000, row 7800. Okay, so I am getting now positive values instead of negative values. Okay, so now sign as reverse. Okay, so might be a correction in this was required, so this might not be a correct value. Okay, you could verify which is correct one. Now it's a matter of debugging and finding out which is correct one. Okay, so now I am getting lambda this positive. Okay, so now you can debug this. If this is also not correct, you can check the formula and what is happening. But I'll go ahead. Once I have received this lambda value, now I can find out the frequencies. Okay, so obviously there will be two frequencies. So I can call what frequency 1. Okay, so lambda equal to twice pi So omega square. So first I need to find out the omega, and then the I have to multiply that one. Okay, so if you see where I have written that formula. So lambda equal to omega square. Okay. For mass matrix Y equal to use instead of plus. That will be also problem. So every time it has to be plus. So it has to be added. Okay, previous mark has to be added. So that we haven't done. We have gone only for the just the replacement. So plus equal to, just like this, minus equal to, okay, and here in this case C plus equal to. So similarly also we have to follow the same way. Okay, let's try one more time. Area 100, E2 E5, length 1000, row 7800, area 50, 2E5, length 1000, row 7800. Okay, so 255 and 17570. Now I got the different result, but somehow these values are not matching. Okay, so now if any other mistake is there, you can find out. Okay, where the mistake is there. Now that is your you have to find out, you have to debug whether in calculation you have made the mistake, or in the program while writing the formulation there is a mistake. Okay, so now this is what I have, lambda equal to 1757 and 2522. So this is what two lambdas I got, and now it's time to get the frequencies. So lambda equal to omega square, and omega is equal to twice pi f. So basically I need to divide square root by twice pi. So that is what I have to do it. So math.sqrt of lambda 1 divided by 2 into math.pi. So I have the pi variable in this, so I will use that. So that is how my frequency 1, and this is frequency 2, so I can use lambda 2, and of course I can console log this. Okay, so now it is going to come, so that is not a very challenging one. Okay, so this is how it is going to come, frequency 1 and frequency 2. You change this variable name also. Okay, so this will come. So even though you write up to this is fair enough, you can do it. Okay, so if you write up to this program, so your this assignment is complete. But you can try on your own. Those who can try, definitely, some of you definitely can try beyond this. So I'm going to explain you the logic which you have to use it for finding the mode shapes. Okay, so now that coding logic you have to develop. So it's a plain thing, again a simple one, scroll down. Okay, So k minus lambda. So again, for this, you could use this since lambda is known to you. So this is my k11 now. I use 1010, and this is m11. Okay. So minus lambda into m11, and this value is okay. So this value is there. Some lambda you put down. This value is going to come. Okay, and this factor will be k12 minus lambda into m12. Okay, so you can put down this lambda and you can get both the factors, this and this. Okay, so this is belongs to u2 and this is belongs to u3. Okay, so naturally what you can do here in this case, you could say my u matrix, okay, will consist of 1. Okay, so it will consist of 1, and u3 corresponds to this divided by, okay, so this factor. So I can call this as a factor, maybe a, okay, whatever this comes, and I can call this factor as b. Okay, so here in this case I can write this as a by b. Okay, and what is common to this is u2. Okay, so just don't consider this, but it is common. So just don't, for programming point of view, just forget about it. So this is my u. This is what I am going to get. So now next thing is, so here this is what I got. So this is my u. Where it is? This is my u, and this is how I write u. So u is common because I have already taken u to be common. So this I can write as 1, and this I can write as a by b. Okay, and this matrix is m. So this is m11, m12, m21, and this is m22. Okay, now you can multiply this and you will get some new matrix. Okay, manually you can multiply, there is no issue. And this matrix is again 1 and a by b. And now whatever the after multiplication, what the results come, you multiply this and you will get some value. Okay, that value here in this case is this c. Okay, c into this u square. So basically u is common, so we are not taking in program. So this is u square. So what is u? U is under root of 1 by c. So in this way you can find out u2. So directly you can write the formula for u2 as 0 this into this, and the second mode shape you can find out as this is u2. So once you got u2, which is equal to 0.0374, okay, and here u3 will be your a by b into u2. Okay, so this is how I will get the first mode shape. So in this way you can try. So this is a pretty simple program, so you have to apply the logic just as it is, and hope some of you will be able to do it. So just let me know whether you understood this mode shape calculation. So you can type mode shape if you have understood this. The rest of the people, have you got this mode share? Okay. So now you try to do it. Okay. Uh, okay. Good.